Now, hopefully everybody had a good Thanksgiving break, a good week off. Hopefully this statement is true for some of y'all. If anybody gets this here. So, what does that say up there below polynomial functions? Well, it's not J, it would be so I over 8. What'd you do over Thanksgiving break? I over 8. I over 8. So, what we're starting today is the last chapter we're going to cover this semester. Chapter 4 is the last chapter we're covering. The chapter that we covered before this break was chapter 4, but it was from the Green Book, so our old book. And that was all over. Yes, if you have any of those to turn in, get those turned in. I will take those pretty much through to the end of the semester. Go on and get those turned in because they are easy points. If you do have questions over any of them, please let me know. I will go back over that or help you if needed. But this last chapter that we're covering this semester is polynomial functions. A polynomial function is what we've covered in chapter 3. Quadratics are a type of polynomial function. And all the quadratics that we covered came in the form of ax squared plus bx plus c. And with quadratics, focus up here, the biggest exponent that we had attached to a variable was 2. And we called it a quadratic because of that. But we can actually have exponents bigger than 2 attached to the variable x. And we have these here. So recall that a monomial is a number, a variable, or the product. And when we put them together, we have a polynomial. A polynomial is a monomial or sum of monomials, because poly means many. So many nomials, many termed monomial functions. Now this here, a to the n, a sub n, x to the n plus dot, 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 or well, a to the n, a sub n minus 1 times x to the n minus 1 plus dot, 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 a sub 1 times x plus a sub 0. All this is just saying any polynomial function. A sub n is just a number. A sub n minus 1 could be the same number. It could be a different number. We're just saying it's a number. A is a number. So it's just saying that it could be the same number. It could be different numbers. We just have numbers in front. X to the n. Well, if we said n was 5, n minus 1 would be 4. N minus 3 would be, or n minus 2 would be 3, going all the way to 1, and then we have 1 without it. So this is just a general way to say any polynomial function. Now the 4 that we have are these here. Constant. A constant function, degree 0, is just a number. They did give us an example of it as negative 14. Would be a constant function. When the degree is 1, we have x to the first power. It is linear. It is an equation of a line. A sub 1 x plus a of 0, or 5x minus 7 would be a linear function. Degree 2, a sub 2x squared plus a sub 1x plus a sub 0, or really the biggest exponent attached to a variable is 2, so that is the degree, and we call it a quadratic. When we say the degree is 3, the biggest exponent attached to the variable is 3, and we call it a cubic function. And the type that we have is x cubed minus x squared plus 3x. Degree 4 means the biggest exponent attached to a variable is 4, and we call it a quartic. X to the 4th plus 2x minus 1. Questions on this here? Okay. Standard form, writing the polynomial in order of decreasing degree from highest to lowest power. So biggest exponent goes first, next biggest goes second, and so on, decreasing to the constant term, the term without a variable. Is writing it in standard form. Leading coefficient is the number in front of the term with the highest power. Now, there are coefficients. Coefficient is just the number in front of a variable. We call those coefficients. The leading coefficient is the one in front of the variable with the biggest exponent. And this kind of makes sense because if it's written in standard form, the variable with the biggest exponent goes first. So the coefficient in front of it would be the leading one. It's the one going first. So it's the leading coefficient. Questions on these here. Now we do need to determine if a function or equation is a polynomial function. And like most things, there's lots of ways to describe what a polynomial function is. And sometimes it's easier not to explain what it is, but to explain what it is not. And that's what we're going to do here. Because it's going to be easier to say what it's not than trying to list out every single possible case of what it is. So if we look at these here. First thing, exponents aren't negative. Exponents cannot be negative, and I would make sure to write these down. So I'm going to put an example. X to the negative 1. X to the negative 1. We cannot have a negative exponent attached to a variable. We could have 2 to the negative 1, that's fine. But I can't have a negative exponent attached to a variable. That's not going to work. Take 2. Exponents aren't inside fractions. I can't have 1 over x. Now, more specifically, the variable cannot be in the bottom of a fraction. I can have x over 2, x divided by 2. X cannot be in the bottom, or sorry, I'm not reading, I'm getting ahead of myself. Because that says what? Exponents aren't fractions. Sorry. That is getting ahead of myself. Exponents aren't fractions. So what's that saying? X to the 1/2. I thought I'd have that flow from it. I didn't even read. Exponents aren't fractions. So we can't have x to the 1/2, x to the 3/4. The exponent cannot be fractional. That's attached to the variable. We can have 2 to the 1/2 times x. That's fine. Numbers can have fractional exponents. Variables cannot have fractional exponents. Third one. Exponents aren't variables. We can't have a variable in the exponent because that's not going to be considered polynomial anymore. That's actually exponential. If you've ever heard of exponential growth, or that certain numbers are growing exponentially, that's what we're talking about, exponential growth. It increases at a faster and faster rate. Variables aren't inside radicals. I can't have the square root of x. Square root, 4th root, 75th root of x. We can't have a variable inside of a radical no matter what it is. Variables aren't multiplied together. X times y. Cannot have multiple variables being multiplied together. Just doesn't work. And hopefully the last one, if Variables cannot be in the bottom of a fraction. Last ones are rational equations. And most likely, if variables are being multiplied together, it's going to end up being a rational equation if we did solve it for one variable or the other. So if any of these here show up, if we have any of these here written in the equation, it is not a polynomial. It's actually a different type of equation. Because our first one, negative exponents, variables multiply together, and bottom of a fraction are all most likely going to be rational equations, not always. Because we can't have variables being multiplied together for circles, hyperbolas, and ellipses, which are not polynomial equations. Inside of a radical is going to be a radical equation. We talked about exponential, and our fractional exponents would actually also be considered radical equations. So let's look at the first part. So there's multiple steps to this. First part, decide whether each function is a polynomial function. If so, if it is a polynomial function, write it in standard form, state its degree and leading coefficient. Okay. So let's look at the first one. We have negative 2x cubed plus 5x plus 8. Are there any negative exponents attached to variables? No. Okay. Are any of the exponents fractional? No. Any variables in an exponent? Variables inside of radicals. Variables multiply together. Variables in the bottom of a fraction. So is this a polynomial function? Yes. So yes, this is a polynomial function. And for the homework, you will end up being rewriting these out anyways, because it will ask you to write them in standard form. Is A written in standard form? Because the biggest term is what? Negative 2x cubed. So we can say our f of x. So negative 2x cubed would indeed be first, and it is written first already. The next term would be our x squared term. There's not an x squared term, so we don't have to write it, which would leave us to the x to the first plus 5x plus 8. So it was already written in standard form. We didn't have to change anything. But on the homework, we'll end up rewriting it out anyways in standard form. Okay, so it is in standard form. Degree is 3. Because the degree is the biggest exponent attached to a variable. The biggest exponent in this case is 3. Type. So this is going back to the previous page. So if the degree is 3, the type is a cubic. That's 3 for degree. Type is cubic. You don't necessarily have to rewrite type, just 3 comma cubic. I don't know what you mean by cubic. And last one, leading coefficient. You can simplify that to LC. I'm not going to make you rewrite out leading coefficient. What would the leading coefficient be? Leading coefficient is the number in front of the variable, or the term with the highest power. So the term with the highest power is our x cubed, and the number in front of it is negative 2. Questions on this here? We ready for the next one? G of x is equal to negative 0.8x cubed plus the square root of 2 times x to the 4th minus 12. Is there a negative exponent attached to a variable? Are there fractional exponents attached to variables? Is there a variable in the bottom of a fraction? Is there a variable inside of a radical? It looks like it, but does the radical actually extend over the x to the fourth? No. So if, a little different color. If it had extended out over x to the fourth, yes, this would not be a polynomial function. But here, it does not. Do we have two variables multiplied together? No. So can we say this is a polynomial function? Yes. Yes, it is a polynomial function. Okay. So our first term would be negative 0.8 x to the third, yes? What's the variable with the biggest exponent? Square root of 2 x to the fourth. Then our next term, negative 0.8x cubed, because our first one is x to the fourth. The next one in order would be 3, so x cubed. The one after that is x squared. Do we have an x squared term? No. Since we don't have an x squared term, we're not going to list it. The one after that would be x to the first, or just x. Well, there's not an x term, so we don't list it. Then the last one would be our constant term, which we do have, which is minus 12. Degree is the number of the highest exponent attached to the variable. So here it is. The first one, it was 3, because 3 was the biggest. This one, it is 4. And 4 is a quartic. And the leading coefficient would be the square root of 2. Leading coefficient is the number in front of the variable with the biggest exponent. Questions on A or B? We're ready for C and D. C. So it is a polynomial function, yes? Why not? We have a negative exponent, 7 times x to the negative 1. That's a polynomial function, not a polynomial. That's it. Because the instructions ask, determine or decide whether it's a polynomial function. Yes, here it's not. Because it said decide whether it's a polynomial function. If so, if yes, if it is one, then do this. Well, this is not a polynomial function. We are done. Because if it's not a polynomial function, we're not concerned with the degree or leading coefficient or the type. So C is not one because of the x to the negative 1. D. Why not? Variable inside the exponent, 3 to the x. Not a polynomial. And that's it. Because it's not a polynomial function, we don't have to define the degree, type, and leading coefficient. Questions on these here? Let's look at 1 and 2, and then we'll move on from here. Number 1, is it a polynomial function? It is. We don't have two variables being multiplied together. We don't have a negative or a fraction in the exponent. We don't have a variable in the bottom of a fraction or inside of a radical. So it is a polynomial function, yes. Now we do need to rewrite it or write it in standard form. The variable with the biggest exponent is x squared. So we would have negative 1.6x squared. Our next term would be our minus 5x plus 7. Since there wasn't a sign in front of 7, it's understood to be positive. So this polynomial function written in standard form is negative 1.6x squared minus 5x plus 7. The degree is indeed 2 because the number of the biggest exponent connected to a variable is 2. So it's 2. The type is a quadratic. And lastly, the leading coefficient. Number in front of the variable with the biggest exponent, negative 1.6. Questions on number 1? Let's look at number 2 before we move on. Negative exponent, so it's not a polynomial function. Actually, it'd be considered radical, but not a polynomial function. That's all we have to do. We don't have to find the degree, type, or leading coefficient because it is not a polynomial function. The next one would be, in its standard form, would be 3x to the 4th plus x cubed minus 6x. The degree would be 4. The type would be quartic, and the leading coefficient would be 3. Questions on this here? Evaluate f of x equals 2x to the 4th minus 8x squared plus 5x minus 7 when x is 3. Plug 3 in. Yes. So if we wrote this out mathematically, what we're finding is f of 3. We're replacing x with 3. So what we'll have is 2 times 3 to the 4th minus 8 times 3 squared plus 5 times 3 minus 7. Now at this point here, you could type this entire thing into the calculator and let the calculator do it for you. Three to the 4th would be 81. 3 squared is 9. 5 times 3 is 15. Minus 7. 2 times 81 is 162. Minus 72. And 15 minus 7, b plus 8. 162 minus 72 is 90. And 90 plus 8 is 98. I think some of you all typed it in. You get 98 as well. Questions on this here? Negative 2x to the 4th plus 6x cubed minus 3x plus 11. You can, yeah. It's just plugging in that value for x. So even if we did have negatives, x to the negative 1, it would still work. They were just applying those properties of negative exponents or radicals. Now, I'm going to show you, I can show you on both calculators. Clear. There. Now, as we've said before, do not just press X, especially when you're typing it in, yes? Because X, the variables in either calculator, represent a number. They have to have a value attached to them, yes? Well, in this case, X is what? Oh, I'm on the wrong page there. Ah, yes, X is 4. For example 2, yes? Now, if you've noticed, they do, on both calculators, do have a button that's STO, stow, yes? That is short for store. So what we can do, either calculator, is I can say 4 store X. 4 store, and then I can pick a variable and hit enter. And what the calculator has done is it's stored that value in place of X. So now anytime it sees X in this here, it's going to say that it is 4, same as typing 4. So what I can do now is negative 2x to the 4th plus 6x to the 3rd minus 3x plus 11. Negative 129. We could type it in with parentheses and get the same thing, or we can do this here. Now this seems like a roundabout way to do this because we have to type a few more things in, yes? Well, if it told me to evaluate this function for when x is 4, I do this here. It also asked me to evaluate it when x is negative 4. So I can say is negative 4 store x. Enter. Now it doesn't see x as 4, it sees it as negative 4. I'm going to use my little arrow keys and scroll up to the previous where I typed the equation in and hit enter. It brings it down. Hit enter again. When it's negative 4, it is negative 873. I mean, typing it in the first time takes a little bit of time, but now I can check multiple values pretty quickly. Because we could say 2 store x, enter, enter, enter. And when x is 2, the value of this is 21. If I want to evaluate, say, negative 2. Negative 2 store x, enter. Negative 63. 3.789 store x. We get this here. Questions on this here? One of the nice things about this is because, again, if we have exponents that are negative, we do need to make sure when we type it in with parentheses, plugging it in, we have parentheses around that variable. Here, doing it by store, it gets rid of that. We don't have to worry about it because it understands that x, that variable in each spot, is negative or positive, and it will act it accordingly. Does that make sense? Kind of. Either way works. If you want to type it in as negative 2, parentheses, 4, close parentheses, to the 4th, and go all the way through, that will work just fine. This will work also. And we can also see why now we tell you not to just hit X on these calculators because it does have a value. And we don't quite know what the last one was set to. Because if it was reset, it resets it back to 0. If it has been set to something previous, it will default back to that. Questions on evaluating? Well, I believe there's one last part. The scary thing called end behavior. End behavior is not as scary as it might think. End behavior, well, as it kind of describes, end, we're going to go to one of the extremes, either positive or negative infinity. As x gets really big or really small, the function is going to do one of 4 things. The polynomial function will do one of 4 things. And it's going to depend on the leading coefficient and the degree. Leading coefficient and the degree. And there's only 4 ways this works out. Draw this out on the whiteboard too. Degree. One of 2 cases. It's going to either be even, or the degree is going to be odd. The degree is either going to be even or odd. Only 2 cases that we have. So the degree is either even or odd, and the leading coefficient is either positive or the leading coefficient is going to be negative. So the degree is either even or odd, and the leading coefficient is either positive or negative. Now, interestingly enough, no matter what the number is, if the degree is even, there's only 1 or 2 setups. It's either they're both going to go up or both going to go down. So the bottom two is what we're looking at because the degree is even. If the leading coefficient, the number in front of the variable with the biggest exponent, is positive, they're eventually going to both go up. Now, if you notice, there's a little dot, dot, dot in the middle. There's a lot of different things that could happen between the two ends. But eventually, if the leading coefficient is positive and the degree is even, they're both going to eventually go up. We could have a whole lot of up, down in the middle, but they're both going to go up eventually. If the leading coefficient is negative, they're both going to eventually go down. So if the leading coefficient is positive and the degree is even, what we say, f of x approaches infinity, positive infinity, as x approaches positive infinity. All that's saying is that x gets bigger, this half here. As I keep plugging in bigger and bigger values of x, the function itself, the y values, are going to go to positive infinity. F of x approaches positive infinity as x approaches negative infinity. As I plug in bigger and bigger, smaller numbers, it's going to positive infinity, it's going up. If the leading coefficient is negative and the degree is even, f of x approaches negative infinity as x approaches positive infinity. And f of x approaches negative infinity as x approaches negative infinity. All it's saying, f of x is the y value. So it's saying as we plug bigger and bigger values of x, as we evaluate it for x, and the leading coefficient's positive, the y values are going to be really big positive numbers. In either case, if I plug in a really big negative number or a really big positive number, the y value will be positive, big positive numbers. Or vice versa, if the leading coefficient's negative, we're going to get really big negatives for the y's. They're going to go down. Questions on this here? Yeah, we will get some examples here. Now, if the degree is odd, they're going to go in opposite directions every single time. So x cubed, x to the fifth. One's going to be going up, one's going to be going down. If the degree is odd and the leading coefficient is positive, f of x approaches positive infinity as x approaches positive infinity. And f of x approaches negative infinity as x approaches negative infinity. As we go to bigger positive values, the y values will go positive. As we go to bigger negative values, the y value is going to be a big negative. If the leading coefficient's negative, it kind of flips on its head. As f of x approaches negative infinity, as x approaches positive infinity, and f of x approaches positive infinity as x approaches negative infinity. Okay. And really the big thing with this here is just getting an understanding of how these functions will behave eventually. And we'll come back to this, especially when we start solving and trying to get an idea of how the function works. But it seems like there's a lot to it, and there's not as much as you might think. So let's look at this first example. F of x equals negative 0.5x to the fourth plus 2.5x squared plus x minus 1. The degree for this is what? 4. And this is even. Yes, it is a quartic. It is an even degree. Yes? Leading coefficient is what? Negative 0.5. And this is negative. Yes? So we have an even polynomial function and a negative leading coefficient. Yes? So on the screen, I'm going to go back a page. So we said the degree was even. Leading coefficient is negative. Yes? There's our answer. f of x approaches negative infinity as x approaches positive infinity, and f of x approaches negative infinity as x approaches negative infinity. That's the end behavior. When it asks to describe the end behavior, that is all it's looking for. Questions on this here? You ready for the next one? What is the degree of this? 3. So the degree is odd, because if we're just describing end behavior, we're looking for even or odd. So the degree is odd. The leading coefficient is positive or negative. Because the leading coefficient, the number in front of the x cubed, is negative 0.3. So we have odd and negative. I'm going to go back to my chart. Degree is odd. Leading coefficient is negative. So it tells me f of x approaches negative infinity as x approaches positive infinity. And f of x approaches positive infinity as x approaches negative infinity. That's it. Now the order in which you put these really doesn't matter. I could have put f of x approaches positive infinity as x approaches negative infinity first, and our f of x approaches negative infinity as x approaches positive infinity second. We could have flipped them. That's fine, saying the same thing. Questions on these here? So really for these, it's just what's the degree? What's the leading coefficient? Match it up to its corresponding part. So here, the degree is still odd, but the leading coefficient this time is positive. So again, we would look back at the chart, and it would tell us f of x approaches positive infinity as x approaches positive infinity, and f of x approaches negative infinity as x approaches negative infinity. And that's it. And the biggest takeaway from this here is more getting an understanding of how the functions should behave, how they should look, how they should work. So when we start graphing them and looking at the graphs, we will know what they should do. Because if on the graph it shows that the two ends of the picture that we have are both going up, and we know it's odd, well, they should be going in opposite directions, so we know one side or the other should eventually go down. And the also kind of tells us which one should probably be going down, which one going up. It gives us an idea of what the graph should do, how it should behave. So when we're trying to find zeros, it'll help us determine where our additional zero should be. Questions on this here? That is it.